live streaming in the browser. The browser is really fantastic, believe it or not. What you can do now that you couldn't do 5 years ago. Are you kidding? Yeah, you can do anything. That's the point. Yeah, you couldn't do anything, but now you can. Fantastic. What do you work on? Hmm. Graphic design. That is fantastic. What are your favorite tools that you work on in graphic design? What are your favorite tools? Illustrator, let's go in the building. What about you? What do you work on? Let's go. Wow. Congratulations on finishing. Let's go. I know what you work on. What do you work on? Cloud. Let's go. What cloud platform? The right one. I like that energy. That's what I'm talking about. So the backstage links should work now that you are speaking. All right. Let's see if we got this one going. We gotta go into that link again. Exit this and do the link from the email. All right. Let me do some stuff here. I don't want to mess with your computer. Sorry. No, you're fine. You're fine. All right. So. All right. I'm gonna click on something. Up the top. So see how it says backstage? That's that top one. That's the right link. You RSVP'd. I'm gonna join. And click backstage. Backstage. That's us. Man, that's me. Can you believe that? Enable presenter mode. Enable. Okay. Allow. I'm clicking. You're good. Everybody, give it up for Mark. I am. Let me get my slides up. You can't give a good talk without some slides. Let me share. Let's see. Chrome tab. And then we're going to start with this. Bop, bop. Oh, that's for the streets. The plug's for the streets. You know, I'm ready right here. Let's see if my clicker is still working. Uh-oh. Oh, shoot. Did I do that? I just clicked the button and then the screen went blank. Is that supposed to happen? Hold on. All right, if you can see my slides, give me one single clap. So on the count of three, here's what I want from you folks. I need a double clap on the count of three. 1, 2, 3. Let's go. I should probably stay in frame with the camera because I walked right past and he's looking like, what is he doing? What is he doing? All right, friends, so listen, my name is Mark Thompson. I am a senior developer relations engineer working on Angular, and I've been hanging out at Google. And I am so excited to be here with you folks to talk about one thing that's very dear to my heart, is really close to my heart, and that is the framework Angular. And I want to tell you what the state of Angular is. Can I get just raise your hand if you have used Angular before? What about somebody who maybe used it before, but then you're like, I'm going to use something else? Anybody use it in the past and maybe they switched? It's okay. You can't hurt my feelings. I want to know the truth. I want to know the truth. Dino was like, I'm not ashamed. I switched. I'm out of there. All right, friends. Fantastic. So let's talk about the state of Angular, because one of the things that's really interesting about what we've been doing is that we've heard so much feedback from the community, from users, and we have been really taking that feedback to heart in the best way possible. All right, I want to talk about some of the changes that we've been making. So what have we been up to as the Angular team? Well, we've been working really hard on just shipping features. Like, we did a lot of talking for a long time, and now we're shipping features. So here's one thing that we shipped that we're very, very proud of. We changed our rendering and compiler engine in Angular to something called Ivy, which unlocked a whole host of new things for us. So we got improved type checking. So if you're thinking about working in your templates, improve type checking. Okay, friends, if you're in the back and you're having a good time, I need you to just like lower your voices just a little bit, because these people are trying to be a part of the party. And it's okay if you don't want to, but they're in here, all right? So do me that favor. I love y'all, though. All right, just kind of lower it in the back for me. Thank you. All right, then we got better debugging, smaller bundle sizes, and more. And these are direct impacts to things that we've heard. Who doesn't want better debugging? Who doesn't want smaller bundle sizes? Now, somebody's in here like, I don't want it. I want bigger bundle sizes. I don't want no good debugging. I want it to be harder. And that's okay because we have stuff for you too. One of our fantastic new features is something called the Angular Language Service. The Angular Language Service is our integrated plugin for Visual Studio Code that allows you to get advanced features and insights in your templates. So a lot of times when you're working with templates, here's what happens. Your templates are in like maybe HTML, and then you have all these data bindings, but you don't have any insights. You don't have any way to know, is there a compiler error, something happening? Well, we wanted to solve that problem, and we introduced the Angular Language Service. And now we've also extended our support for the Angular developer tools. So now in Chrome and other major browsers, you can get insights into things like your change detection cycles. You can get insight into your dependency injection trees. I mean, a lot of things that are really important to developers who are trying to build maintainable, scalable applications. And here's something that's really fantastic. Somebody give him a round of applause. Somebody give him a round of applause, right? It doesn't work on Internet Explorer, but it works in all the major browsers because we want to meet developers right where they are. Sure, Dino, what's up? I said major browsers. Not the same, not the same. But we work across Chrome, Edge, Firefox, which is a huge deal because this covers so many major, so many platforms that developers are using. And if you do use Opera, here's what I want you to do. I want you to just tweet at us at Angular on Twitter, and you represent it. You let us know that you want Opera support, and we will not make it. But you can let us know that you want it. But here's a feature that's coming soon to the Angular developer tools. Again, if you are an Angular developer, you know that the dependency injection tree is something that you need insight into. Well, we're working on a brand new view that you're going to be able to see in Chrome developer, in the Angular dev tools. Brand new feature. This is going to change the game, and we can't wait for you folks to be able to give it a shot. Now, as a developer, there is one thing that is probably your greatest strength in solving problems. And that's when you're debugging and you're looking at stack traces. Regardless of what framework you work on, is your ability to look at that stack trace and then try to source of the issue. But if you've worked in any framework, including Angular, you get these stack traces that are really complex. So there are two things I want to talk about that we've been able to make some very exciting improvements in. One, the error messages that you get. I, for one, have spent time trying to understand the error message about the error that I got. You ever been there before? Anybody ever been there just trying to understand the error message? So now on the Angular team, we've updated our error messages and given you a code that you can use to look it up. And we have explanation videos onto how to fix it. So this is a major improvement, something that we worked really hard on. We're very, very proud of. Here's something else we're really proud of. We've partnered with the community to make some important changes to the other parts of the tooling for the framework. We now have partnered with James Henry for ESLint, which is going to give you linting support in your code, a community plugin, not something from us, from the Angular team, but we understand that sometimes the best tools don't necessarily come from us. And we want to partner with the community and make decisions accordingly, following that thinking. We've also partnered with the top programs that support end-to-end testing in the community as well. So now, instead of using Protractor, which we deprecated, which was a tool that we was like, hey, we were working on it, we were maintaining it, but we felt that, this just isn't the best, this is not the best tool. And people want something different, so we added support for Cypress, Nightwatch, WebDriver IO. I think there's also support for Playwright. So you have top tools out there. Well, you can use them when you're doing your end-to-end testing with Angular. Sure. Just the ones on the screen here. So for end-to-end testing specifically, we also support Playwright, which is from Microsoft. Excellent question. All right, let's talk about builds, because build times is a thing that no matter what you work on, people care about this. People want to know how to get faster builds. Well, we also want to know how to get faster builds. And what we've been experimenting with is something called ES Build. All right, so we had Terser as a part of our build pipeline. We removed Terser and started adding more references to ES-Build to get some really nice, really nice output. You see that number right there? That's more than half. So we got a code build using our new experimental ES-Build pipeline. You're getting 57% faster code builds. Thank you so much. That is so fantastic. Look at y'all. I'm so glad you're excited. That is so good. Yeah, I feel really great about that. I mean, I could have put 100% of y'all. I'm like, and? Okay, Dino, I'm telling you, Angular, I know you're still young in your developer journey, but Angular might be the future for you, just saying. All right, but in general though, because when I opened up, I told you about the IV engine when we changed our renderer and compiler. That's what led to a lot of these things being possible. And so here's something that's really interesting. Internally at Google, right, we have over 2,500 projects that use Angular, more than 2,500, and that number continues to grow. When we changed all the projects internally to use Ivy as the only rendering engine, right? This is what we saw. Some projects, 90% less resource usage doing builds, all right? Thank you, I like that. Keep that energy going. That's what I'm talking about. And 30% smaller bundle sizes. So Ivy has really had a material impact on Angular, on the lives of Angular developers internally and externally. Sure. Oh, good question. Well, that's kind of what we're talking about here with our resource usage, right? So we're trying to reduce the amount of RAM that it takes for your build, right? We're doing our best to help with that. I mean, Angular is the best alternative to everything, and with web frameworks, is my opinion. In my opinion. All right. Angular continues this one core tenet all the time, and that tenet is we don't want to break our users. So we try to release everything where we move everyone forward together. And so when we changed from Ivy, there was not a hard fork between our previous renderer and compiler to our new one. We actually changed it while people were building Angular apps. And if you've been using Angular, you probably didn't even notice that we changed it. So it was kind of like we changed the engine of the car that you were driving in while you were driving it. Yeah. Well, and it's pretty, I know that's impressive, right? He's so impressed by that. I'm glad you're impressed by that because that was a lot of hard work from the Angular team to make that transition happen. And we continue to release features in such a way that they come out and they don't break our users. Yeah. Jessica is on the Angular team and she knows all about a lot of this magic. All right, so let's talk about what's next for Angular. That's what let's go. Round of applause for that energy. That's what I'm talking about. Thank you, Dino. I did not bring him with me here to support you like this. This is just genuine support, which I am very happy for. This is fantastic. All right, so when you're building Angular apps, one of the things that happened before was if you had to create a component, which is our primary building block for the user interface, you had to do a lot of stuff. You had to create the component, you had to find a way to like register it, lots of boilerplate, lots of configuration. We changed that with the introduction of standalone components. So what a standalone component allows you to do is build a component without all the boilerplate. So faster development, smoother development for users. I know. That's what I'm talking about. Yeah. All right. So when you're going to build it, so here's what the authoring format looks like when using an Angular standalone component. Now you can bring in your dependencies. You just mark the component as standalone in the metadata for the decorator, and then you start writing code and it just starts working, right? Any dependencies you need for your template, you just say what they are. And now we're not lost in a complicated dependency tree that was very challenging for people to learn and understand Angular before. So this has gone a long way to simplify the path to getting onboarded. Are y'all creeping up on me because I'm out of time? Okay, just making sure, because Rhea was walking up slow, like, okay, that's all. Listen, I just want to make sure. So here's what's funny about it being a developer preview, not for much longer. Since we announced it in version 14, we're going stable in just 2 weeks. Woo, I know. Stable in 2 weeks, and it'll be ready for production, and you'll be able to build apps that use standalone components that bootstrap from standalone components. Fantastic experience for people learning Angular and learning how to get started there. There's some other things here that we could talk about, considering that now there are things like functional route guards. And so if you've written Angular code before, you know that a route guard would have taken lots of extra work to do. We're like, yeah, let's get rid of the extra work. Let's make the path smoother. Now we have support for functional route guards. We're also working on something very special. This is something that's very, very dear to my heart. Brand new Angular tutorial. So I'm currently working on a brand new tutorial that is designed for people new to Angular with the understanding of what it takes to get started in a web framework. This is a project that I am very passionate about, that I spend all of my time working on right now. So brand new Get Started tutorial coming very soon. Can't wait to launch that, and can't wait to see how it impacts the lives of developers wanting to learn Angular. But we're not stopping there. The team, the docs team, is working on brand new guides. We're working on brand new examples. We're working on just a lot of stuff to make sure that the documentation is always working on your side, in your favor, to guide you where you want to go with Angular. All right, let's talk about Angular and conformance. Conformance is all about the strong defaults that help you build better applications from the start. Angular, as many people have heard, we're opinionated. We think we know what some defaults are that you should have to build better applications from the start. One of those goals, one of the projects to hit that goal was typed forms. This was our #1 issue in our GitHub repository, and we launched it this year, and we have been getting some really fantastic feedback, because now with typed forms, you can surface errors during compile time that your users would find during runtime. That doesn't really give the best experience, right? Like, you don't want your users to enter their address and then you get a type you weren't expecting, and then things kind of go awry from there. Well, type forms helps you to catch all those errors early in compile time. So you can find things like properties that are missing, like there's no email in this form. Okay, you can find that at compile time. You can find the wrong type. So let's say someone says, oh, wait, this form is of type number, but let me run substring on it. Catch that at compile time. All right, what about you trying to reset the form values, but then you're missing a property that you need? For example, this is trying to set the value of the form for the lives property to 4, but we're missing one. And it's not marked as optional, so it should be included. Well, guess what? Catch this when? Lights and loud. Compile time in here. At compile time. That's what I'm talking about. Compile time is giving you life. You catch it at compile time before your users run into those issues. All right. Let's talk about moving everyone forward. One of the things that we find to be a fantastic support of our community is this one website called update.angular.io. If you want to go from version 12 to version 14, you can use this website, and we'll give you recommendations on how to smoothly migrate your projects. That sounds like we care about you and your projects. Like, that sounds like a lot of like care and love, because we do. We love y'all. We want y'all to continue to build great apps. You are so welcome. Okay, you are so welcome. All right, let's talk about a peek into the future about where we're going with Angular. Accessibility. What? Oh, I thought he said time. All right, accessibility is a core part of any applications. I personally believe if you can't make it accessible, if you can't build for everybody, you shouldn't build for anybody. That is my core belief. You should make all your applications accessible. Build for everybody, or don't build at all. So we're trying to continue. Oh, I appreciate that smattering of clapping. That was good. All right. So streamline accessibility. We're doing things like this, where this title property may seem like, you know, a small change, but whenever you're building a single page application and you route to a different page, what commonly happens in that page? The title does not change. And it's actually quite a bit of work to make that change. You have to get the browser object to start, blah, blah, blah. Yeah. So that makes it harder for you to make it accessible. Built in on your routes now. Fantastic. Built in your routes. I know. Look, you know how I was just talking about compile time and finding things? What's really hard is when you type something that's syntactically correct, but logically incorrect. Well, we have the extended diagnostic suite of tools that can work on your code to help you find problems that, while they are syntactically correct, they may be incorrect logically. For example, If you're going to do a two-way data binding in Angular, there's a syntax called banana in the box. Let me say banana in the box. I know, so that means you got a square bracket surrounding parentheses, but you can type parentheses square bracket. That is not syntactically incorrect, but that is logically incorrect. That is not what you want. We have tools now with the extended diagnostics that helps you catch things like that. Yes. Oh no, that's O2. Sorry, see my slides are not designed good enough where you can see that. That's my bad. I'll make that change. Yeah, that's O2. So just like number 2. But thank you. No, that lets me know that's not visible, right? So I need to change that. All right. Then we're also doing some stuff with our command line interface, another tool that we try to do things to help you build great apps out of the box from the start. So we have a lot of stuff like this, the NG Analytics. You want to control the data that is sent from your application through analytics. You have even finer grain control here. All right, we want you to feel comfortable and know what you're sending, turn it on and off. Clearly, no digging through lots of files to do that. NG Analytics, you can just turn it off. We have caching for your builds to help give you even faster build time. So we've updated our caching algorithms here as well. You got NG completion. So from the command line, you might not remember a tool like the name of one of our arguments. Guess what you can do now? Hit tab for autocomplete. We're just trying to help you and just trying to make your life easier. We want you to build great apps. I'm not kidding about that. That is our core tenet. We're in there. All right. Now, let's say you don't want to install the Angular CLI globally because you're like, I want the tool, but I don't want it polluting my global NPM namespace. You no longer have to. You can just do yarn create it per project. Have your version per project. We also have the NPM alternative working for you as well. We don't have it for Bun. I know some of you are like, what about Bun and TurboPack? That's new. Somebody asked me that. Somebody literally asked me the other day. They're like, hey, Mark, when is Angular going to incorporate TurboPack? And I'm like, TurboPack came out last week. How are we going to incorporate that? Come on. Come on. All right, friends. I know I'm running short on time, so I'm going to go over a few more things that have been happening in the world of Angular. Let's talk about Web Vitals. All right, so how fast your page loads, your largest contentful paint or your LCP impacts how your users perceive and interact with your application. So Core Web Vitals, we partnered with the Chrome team, and we did a lot of work to figure out how to improve the Core Web Vital score. Guess what? We found out. We found out once we worked with them, we got 110% improvement in the Core Web Vitals. Thank you for that. That is fantastic. That's more than 100. That's like an A++. You see what I'm saying? I mean, okay, so honestly, my job is really done because he is so excited about that. Like, I feel like I won today, so I don't care what else happened. That has made me so excited. Fantastic. All right, here's something that's really exciting. We did another partnership with Chrome. Now, this is really fantastic. I know I say everything's fantastic. I know you heard me say that like 10 times today, but this is so fantastic. All right, out of the box, listen, there's a box, right? And then you come right out of it. Out of the box, we now have the NG optimized image. All right, now what does this do for you? It does so much to help you with your largest contentful paint. This new directive that comes with any Angular app, nothing else to download. It'll help you, give you hints like, hey, set your height and width on your image. It'll give you hints like, oh, let's set the priority for this image to be, lazy loaded or preloaded. I mean, fantastic optimizations for your image that you will be told about just by adding the attribute ng source. Just add the ng, just add it right in front of that. You see what I'm saying? So now you'll get all of these fantastic updates about how to better optimize your images. And what does that lead to? Better performance. What does that lead to? Better experience. What does that lead to? Happier users. And that's all for you outside of the box. Let's go. Let's go. Remember, I hinted earlier to the stack traces, and I said how messy they could be. Stack traces are hard. It's hard to read those things. But guess what? Why are they hard? Because one, this is the actual stack trace that you might get. But what part of the code did you write? Where's your stuff? And this isn't even really unique to Angular. This is just a web framework problem. As you include more dependencies, it just happens, but we care about you. What did I say? Did I say we care about you? Guess what we're doing? We're changing it to only include the relevant parts of the stack trace. So now you can see these are asynchronous parts of the code. So asynchronous calls are also very hard to debug. But now we'll let you know, even with the asynchronous parts, oh, it goes all the way down to app.component.html line 4. Okay, that's pretty good, right? That's okay. That's okay, but we can do even better. This is where we're going, letting you know all the way down to your template line with the relevant HTML. This is where we're going. You are so welcome. I know this is a big deal for people who are constantly reading stack traces. This is what we're getting to. This is something we're working on for next. I won't say next quarter, but like next year, we're working on it really hard to get all the way down here. But this first part, like up to this is going to be live in 2 weeks. Yeah, the relevant stack trace is live in 2 weeks when we release Angular version 15. That's coming for you. And then this is the next thing we're going to do. And guess where it's coming? Out of the box, version 15 by default. All right, friends. Couple of more things here. We got hydration. The hydration story is a hot commodity right now. So how does your page get rendered? Are you server-side rendering, and are you including everything on the server-side call so that way when it gets to the page, it's really, really fast? Really fast. Okay, so we're trying to figure out, well, what does Angular fit in this picture? And not only where do we fit, but how can we innovate in this space? And we have to do something that makes sense not only for just appeasing like the zeitgeist of what's happening right now, but what actually improves the lives of our developers. So we're spending lots of time trying to solve this problem right now for Angular. What does it mean for Angular and the Angular community? Here's something really fantastic. It's the Better Together story. I was just in New York 3 weeks ago doing a live workshop with the Firebase team because we want to continue to show how Angular and other Google products are working better together. There are already workshops and examples. There's a code lab that just went live this morning where you can use Google Cloud Platform and Angular to do like chat bots and stuff. Like super cool stuff is out there. And we're going to continue moving down on this Better Together story with Angular. You might want to know, well, Mark, you said a lot of stuff. I only heard half of it because you're talking so fast. How can I stay in the loop? What can I do? Well, we commit to transparency on the Angular team. So you can go to angular.io/guide/roadmap, and you can find out exactly what we're working on, what's the updates on it, and then how you can participate and learn more. One of the things that we're very passionate about is the RFC process, the request for comments. So we like to hear your feedback as we're developing new features before we just go and change your entire developer world. So you can participate. We want to hear from you. We want to know what's happening. And then finally, friends, my name is Mark Thompson. I am so grateful for your time and attention. Thank you.
Oh, you got a question?
No, ask questions. Correct.
I know Angular supports TypeScript, right? But Cypress, you can write the test only in JavaScript. As far as I know, how do I use Cypress and Angular in this case?
Oh, good question. I have not written a Cypress test in Angular.
Selenium and the Cypress testing tool.
Yeah, I know. Selenium.
They have their own
True.
script, but it doesn't matter what is in the front end. At the end, all
the test runner will run it in JavaScript, I think is what we're getting at.
Yeah.
Okay, no, great question. Yeah, so I think your test runner runs in JavaScript, even though the other code will be in TypeScript.
And there's probably typings for any kind of Cypress test that you're going to write. So you should still be able to write it in TypeScript, and it'll just get compiled down into JavaScript. So you should be fine.
Yeah, great question. All right, I've been notified that my time is up completely. I'm so sorry, but thanks again, friends. I really appreciate you.
Thank you so much, Mark. Awesome. Okay, so next up is Justin Fagnani. Did I say that right? Okay, with a talk about Lit. And in this room is in progress the talk when Daniel Goncharoff and about a survey of the state of the art and language models for code. That sentence is hard for me to say, sorry. But they're almost done with that. And then, yeah, so welcome, Justin. or?
This one's fine.
Okay.
Thank you, everyone. 1 second while I get things projected here.
Oh, there you go.
There you go.
Okay. I just did that, so hopefully they have. And then- Okay. I'll stand over here. I guess everybody ready? Yeah.
There you go.
Okay. Let's see. Check. Check. You heard about Lit? Awesome. Yeah, so I'm going to dive into a very specific topic about Lit. So I hope that's okay because I do think a lot of people haven't heard about Lit. And so we're going to go into some details about Lit styling. And hopefully I can set some context so you can roll with me here as I do a deep dive in the styling there. But first, my name is Justin. I am on the Web Components team at Google, and I am one of the creators of Lit and work on that team there. And so this is Lit in the logo. Maybe a lot of you haven't heard of it. So Lit is a simple library for building fast, lightweight web components. The web component part is really critical here. Lit wouldn't exist if it weren't for making web components. Its whole goal is to help make it easier to make web components. And these words here, simple, lightweight. So what do we mean by that? Simple. So in our team, we don't believe in having to make you use a particular tool chain or compiler. So you can use plain JavaScript or TypeScript, no compiler. Yes. Yes. I should have the repo up here. Since I'm diving into CSS, I don't really have that. I will tell you, it's GitHub lit/lit. The org is lit, the repo is lit, everything is there. So yes, it's very simple. It's just plain JavaScript and CSS. Web components are a critical part of this because web components are interoperable. Web components work in any framework. They work in React, Angular, Vue, Svelte, Solid, plain.js, Markdown, your content management system. So web components are really the reason for us existing. And lightweight. The whole Lit package comes in bundled at less than 6K. And this gives you reactivity, scope styling, state, declarative templates, all kinds of stuff. And in terms of fast, we're very fast. We're the fastest frameworks out there, probably the fastest of like the top 5 to 10 frameworks by downloads, by NPM downloads a month. So that's a little bit about Lit. Oh, and Lit is great for things like making interoperable web components. Like lots of design systems are built with Lit because people who make these design systems have customers who are using all kinds of different frameworks. So you can build Leaf style components like Material Design here. But it's also good for building entire apps. So Photoshop for the web is built with Lit. And so desktop class complicated apps can be built with Lit for sure. And so what does Lit look like? So here's an example of a Lit component. This is a pretty kind of minimal but standard setup here. We use classes and you extend Lit element, which in turn extends HTML element. So here you're making a new HTML element. And most components in Lit are going to have at least these two elements here. We have styles and a template. So the styles are here in the static style part, and the template is this render method here, which is very similar to React, right? And so for this talk, I'm going to concentrate on the styles part right here. And we're going to go dive deep and even deeper than we go in our normal docs. So this is intended to be a little bit of a mind-blowing that you can do this kind of thing. Maybe there's some sharp knives here and maybe you shouldn't do everything I'm about to tell you, but you can do it nonetheless, and that's what kind of makes it interesting to me. So yeah, you have a component, it has some the styles right here. This is standard CSS. So This is CSS and JavaScript, even more literally than most CSS and JavaScript libraries are. And if you follow the discourse on Twitter, you'll hear that CSS and JavaScript is bad, evil. And it turns out that some variants aren't very bad. One reason why we went with this is because it's plain CSS strings inside of JavaScript. Let me go here, yes. And it turns out that this meets a lot of requirements that we have on the lit team. So we have this requirement that you don't have to use a build system. You can actually write a lit element in DevTools in the console. We also want to use standard languages. We just want to use JavaScript in CSS, and this is plain CSS here. We also want to make sure that even though we're not using a compiler or a tool chain, we get good behavior nonetheless, right? And we want good loading behavior here. So one of the things is we want to make sure the CSS loads before your component renders, so you don't get a flash of unstyled content. It turns out putting the CSS right in the JavaScript module lets you do that. So we're pretty happy with how this turned out. The performance is good too, because when JavaScript is parsed, the performance of parsing is not equal for all JavaScript. Parsing strings is really, really fast, because as soon as you hit this one backtick right here at the CSS tag, the parser goes into string mode and it just consumes all the characters it can until the end. So the overhead of parsing the CSS in JavaScript is extremely low. The parsing is like 3 to 4 times faster than generic JavaScript expressions. So yeah, we're really happy with the DX and the performance of how this turned out. And so lit doesn't really do anything with the CSS. It kind of attaches it to your component and then lets the browser do the rest. So what we end up having is this combination of 3 simple platform features here. We have JavaScript, CSS, and Shadow DOM. You might not have heard of Shadow DOM, so I'll go into that really quick. But what this talk is about all the power and complexity and interesting things you can do when you combine these 3 simple platform features. So I'm going to go into a little bit about how this works, cover some really quick basics on loading and sharing and scoping, the stuff we usually talk about. And then I'm going to get into the really wild stuff. And finally, I want to talk about like what maybe the web platform could learn from this type of technique. So, okay, how lit styling works. So the first thing we do is we take your string and we create a style sheet object, right? And then the next thing we do is we attach that style sheet object to our web component, to our element. And then that's it. There's no step 3. And I want to give a little demo about how this works. So let's see if I can do this. So this is our website here, lit.dev, and we have an interactive playground here. And what I did here that I want to demo is I built a little lit-like system. So this is not lit. This is something that I have in this one file that's about 55 lines long. And what this does is it lets you do a very lit-like thing. We can specify some styles here, and we have a template. And to show you how this works, I have an implementation here. The first thing that we need to build is this CSS tag. This is called a tag template literal in JavaScript, and this lets you interpret the string in a custom way. And we have a CSS tag here. This is the tag template literal function. It gets the strings and any values you might have interpolated into it. And we build a string from the interpolations. So this just kind of reduces the strings and values together. And then we just simply create a new style sheet object. We set the text of the style sheet object to the text we got from our template. And then we return that together with the CSS text and the style sheet and this branding that we're going to use for security. I think I'm going to have to gloss over that right now, but the security feature is that we don't allow you to put random strings in CSS. That could be a XSS vector. People could exfiltrate data with URLs in your CSS. So we don't allow strings. It has to be like a literal in your program. Then the next thing, once we're able to make what we call a CSS result out of this template here, is we need to apply it to our element. And here we have a class that extends HTML element. And in the constructor, we're going to do some work. So we create a shadow root, and then we collect all of the CSS results for this element. And we support an array of results here. So we're just going to call array.flat, which is one of my favorite new JavaScript APIs to collapse an array of nested array of styles into one array. We're going to get the style sheet objects from that array, and then we're simply going to push them onto what's called the adopted style sheets. Now, this is an API that lets you take style sheets and just attach them to the DOM. You don't have to have a style tag. You don't have to have a link tag. So we get the shadow root, we attach the style sheet there, and then it's scoped to that particular style sheet. Those styles do not leak out anywhere else. And this is all standard JavaScript DOM APIs. These are built into the browser now. And then finally, we're going to call our render method, and we're going to use the lit templating library here to render that to the shadow root. And you can see now we have this element, and we have hello styles, and we can go change the color to blue. That should, oh, I should learn how to type blue. There we go. And so you can see we're able to apply these styles to that shadow root, and I'll get into the scoping, how it doesn't leak out later. All right. Let's see if my slides will advance. I broke something. There we go. All right. So let's cover some basics real quick. This is the stuff we talk about in our docs, and we talk to most people about how to use CSS and lit. So the first thing is loading. I mentioned that we want things to load, we want the styles to load before the element ever renders. And one way to think about this is that CSS is just another dependency of your element, just like any JavaScript library it might use. So you can see that we get good loading behavior kind of obviously if the CSS is with the component. This is like a single file component, but in JavaScript, right? You have logic, template, styles, right? But it turns out because the CSS is just a variable and it's all just JavaScript, that you can slice and dice this any way you want. So you can put your styles in a separate file here. This might be good if you have like a huge style sheet. You want to kind of focus on that in a separate editor, or maybe you have a huge amount of logic and you want the styles out of the way. So here you can see we put the styles in a separate file, and then we import them into our element, and now we just assign them to that same static field that we had before. And you can do this with, there's no kind of API or overhead or compiler that does this. It's just JavaScript, right? And one nice thing about this is you can look at this as a dependency graph of your files that you're going to load into your page, is that it's just JavaScript, so the JavaScript module system loads everything. But the other cool thing is that if you bundle your JavaScript files, it will bundle the CSS automatically. Any bundler will do this. You don't have to have a plugin for the bundler that's like CSS modules or something like that, because the CSS is just in JavaScript, right? You know, even though we don't require tool chains, by being standard all across the board, we end up working automatically with any tool chain. And an interesting thing that's coming down the line is right now we have our CSS in JavaScript files. There is a standard that I helped propose and usher along, actually, that's implemented in Chrome and Edge called CSS module scripts. And this goes along with a thing called import assertions. And let me see if I can get my little highlighter here. What an import assertion is after your import, you can put this assert type. And this tells the browser that you're importing CSS, not JavaScript. And what happens is when you import this, oops, I have a typo. There's supposed to be no braces there. When you import this, you get a style sheet. So get a style sheet and then add that anywhere in the document where you want to. And then, so now on the right-hand side here, we don't have JavaScript anymore. This is a plain CSS file. So this is called CSS module scripts, and it's shipping in Chrome and Edge now. And Firefox and Safari are on their way towards implementing this as well. Okay, and so then that would give you this dependency graph here if you have your JavaScript depending on your CSS. Now let's go into sharing. So it's very common that you might have a lot of components that want to share some common CSS between them. So what we can do here is we can have two components, my element and my element 2, and they both import the same style module. And this just works again because it's JavaScript modules. Another thing that you can do is we support arrays in this styles field here. So you can import shared styles and then add the more specific styles for your component as another style sheet in here. And again, it's all just JavaScript. So if you import this from HTML, it'll import your two JavaScript files. They'll in turn import the style module, which will be deduplicated because of the JavaScript module system. And again, it works great with bundling. So if you bundle all that, your bundler will do the right thing. And it really works well if you have multiple entry points to your bundler. So a lot of CSS systems out there try to help you do things like load just the critical CSS for a page, which is the styles needed for the above the fold, the visible portions of the page when you first load it. And one nice thing about associating styles so tightly with components is that if you can figure out your critical components, then you've automatically figured out your critical styles. And if you bundle the components, you bundle the styles. Oh, 5 minutes. Wow. Okay. Yeah, I'm going to jump ahead a little bit. All right. So we get a lot of great behavior there. And then we also get scoping. So Shadow DOM is a special area a component can put their DOM in their styles, and the styles do not leak out into the page. Right. And so I have a diagram here that tries to show the purple part is the element's internals, the gray part is the external part of the element, and they do not collide. You can use a P selector, and that's not a problem because it will not select any other paragraph elements in the page. All right, let's get into the superpowered CSS now. So we're going to look at just the CSS here. One of the first things you can do is use variables. So this is a JavaScript expression inside of the CSS, right? And so we can just extract out constants into variables. And one thing you'll notice there is that we have JavaScript in our CSS, but we had CSS in our JavaScript. So what we actually have here is JavaScript and CSS and JavaScript. And it actually all ends up working very well and being very powerful. And if we think about kinds of things that we might want to do with this power, we can look at other CSS systems. SAS has variables and mixins and whatnot. Tailwind has utility classes. CSS modules will let you import obfuscated CSS classes. And so you saw variables there. You can interpolate a variable right into your CSS. That's pretty nice. And you can also do operators. So once you have JavaScript expressions in CSS, you can do math. You can do string manipulation. You can do anything you can do in JavaScript in there, right? I showed you about modules, right? So you can import styles from another module. That's great. But then here. And so here's one. I'm going to skip the demo on this. Hopefully you can imagine how this works. But if you can call a function in the middle of your CSS, you can make a function that returns a snippet of CSS. And this function even takes parameters. And then when you apply that function to your styles, you copy all those declarations into your styles. And so now you can have this awesome text mix-in that you apply to styles all over your application. So you can encapsulate and abstract some logic there. And we don't have a special system for this. Again, it's just JavaScript and CSS. You can even go so far as to completely generate entire style rules. So in design systems, it's often common that you'll have variants of some of your components, right? So you might have a button that has different styles for the primary button, success on a form, neutral, or a warning button. And they might have very similar styles but use different colors. So here we're going to like map over this set of variants right here and produce styles that use CSS variables with a different name. So we're actually going to like dynamically generate the CSS variable names here based on this variant. And this would actually expand out into quite a bit of CSS. So the JavaScript can actually be a compression format here, where the form you write it in and the form that goes over the wire to the browser is a lot smaller than what it would have been if you like generated all this at compile time. So another really powerful thing you can do with lit is you can be dynamic in a way that is very difficult to do with current CSS systems. So I have some examples here of how to kind of apply styles targeted to an element. But since I'm running short on time, I will get to this example here, which is dynamic scope styles. So normally you put CSS into that string I showed, that static string on an element. You can also just put CSS in a style tag in your template. So right here. And the nice thing about this is that once it's in your template, you can add expressions there that are based on the state of the component. So here we have reactive state for our component, this elevation. And we want to adjust the shadow property based on that. Well, we interpolate that into the style tag. And now normally you would think, well, if I just put code into a style tag like that, that will leak all over the page and all kinds of elements will get these different styles. Because this is in a shadow root, each particular element is scoped individually. The styles here will be scoped to this element based on that element's state alone. Another element could have a different value for the same property here and get different styles because of it. And this is something that's very, very hard to do with other systems. How am I doing? One more minute. Okay. I'll show a little experiment I did last night as I was trying to work this up. So Tailwind is very interesting, right? I'm going to skip to the Tailwind one. It's pretty popular. One of the things that's popular about it is that you can use utility classes, and then it has a compiler that goes and takes the huge, like 2.5 megabyte or something Tailwind CSS file and reduces it to just the ones you used. Well, we also do this in JavaScript a lot. It's called tree shaking. And it turns out that with the power of lit directives, you can have a system where you import little snippets of style like this. So sans is font family, sans serifs, red is color red. You import just the ones you want to use. You apply them to the elements in your template. And we have the special mix function, which is going to inject the styles as well. And it turns out if you run this through any kind of tree shaking dead code eliminator, that if there were other styles in this file, it would throw them away. So we get like Tailwind with no compiler as well. That kind of brings me to the end of it here. Yeah, it's okay. I went a little too long here, but hopefully this was interesting. Yeah, combination of JavaScript, CSS, and Shadow DOM can lead to a lot of powerful things. All right, thank you.
Thank you so much, Justin. That was great. Awesome. Okay, so next up we have in this room, we have an intro to gRPC with Go from Iswar, who's coming up here. And in the cloud room over there, we have similarity-based machine learning by Hannes, who's just starting now as well. So choose whichever one you want to go to. Don't be shy. It's okay. I think it's a lot more empty in there than it is out here. So, do you want this or do you want that or? What do you think?
Take that.
Okay. And then. Are you good? The plug.
So you plugged in already.
Oh, you're set. Oh, you need the microphone and camera. Give it permission.
Now, if you click on start video,
Start video.
yeah, and I'll just you're gonna unmute yourself, and then you can also share your screen. That is well.
Good afternoon, everybody. So my name is Ishwar, and I am a software engineer on the gRPC Go team at Google. So before I get started, how many of you all have heard about gRPC? Ooh, how many of you actively use gRPC? Ah, nice. So this talk is just an overview of gRPC, and for people who are completely new to gRPC, this will be a good intro. And before I actually get started, just a couple of things that we're very happy to share. We just got the best in microservices infrastructure just last week. And just to give you a sample of how popular we are, 5 million weekly downloads of the Node.js gRPC, 2 million per day for the Python gRPC, and 12.5 million for our Java gRPC. So before I actually just dive in, I have a small question. Anybody knows what gRPC stands for? Good try. So gRPC actually stands for gRPC, remote procedure calls. So it's basically a recursive definition. Yeah. So the G doesn't stand for Google. So each of our release is named with the words G, and our first release was named gRPC, and our most recent release was named Galley. So at a high level, gRPC is an RPC framework which is high performant and open source. We are a CNCF incubation project. So that means that we are stable and we are being used in production successfully. And we are hoping to graduate sometime next year. And so just a little bit of history of how gRPC came about. So we have this internal RPC framework in Google named Stubby. So all Google services end up using Stubby for communicating within their components, like service-to-service communication, and to talk to other Google services. And just to give you a scale of how big Stubby is, it runs something like 100 billion RPCs every second in the Google production network. And the team that built Stubby wanted to build the next generation RPC framework, and that's how gRPC came about. And the decision to open source gRPC was made quite early on. And this is just a few of our users. And the one on the right, that is a golden retriever named Pancakes. That's our mascot. So is gRPC high performant? Reasons is that it's built on top of HTTP2, and therefore it gets all of the benefits of HTTP2. And one of the major reasons for HTTP2's improved performance compared to HTTP is that it's a binary protocol. So here on the right, we see an example HTTP1 request, and we see that it's in plain text. So when that becomes a HTTP2 request, it gets converted into binary, and they're packed as frames. So the frame is the smallest unit of communication in HTTP2. And each frame carries data of one particular type. So here we see a headers frame and a data frame. So at a very high level, a HTTP2 connection between a client and a server carries multiple streams. And each of those streams carries multiple messages. And each of those messages is actually broken down into frames like this. And all these frames from different streams actually get multiplexed onto the same connection. So this is one of the major reasons for HTTP2's performance gains. And it also supports header compression. So one of the other reasons for gRPC's performance is the use of protocol buffers. Any of you heard about protocol buffers? Cool. So protobufs are a mechanism for serializing structured data. So you can think about them like JSON or XML, but it's just that it's faster, simpler, and much smaller on the wire. So the protocol buffers actually comprise of a bunch of things, specifically the first 4 in this list. So it actually defines the syntax for the language used to specify the structure, which is called the IDL or the interface definition language. And it also provides a compiler, which takes in this IDL and spits out code in multiple languages. And it also provides runtime libraries to actually perform the serialization and deserialization. And it also specifies the serialization format on the wire. Now, another important aspect of protocol buffers is that it supports versioning and is forwards and backwards compatible. So what this really means is, like, if you imagine a client and server, or just about any 2 processes talking to each other and exchanging protocol buffers messages. And let's say that you want to add a new field. Now, when you're rolling out that update, you're not forced to ensure that the update is rolled out to all of the processes at the same time. So you can have a staggered rollout, and the protocol buffers work even if one entity, which is built using an older version of the protocol buffer, is talking to another entity which is built using the newer version. So how does all this tie into gRPC? So as we said, gRPC is an RPC framework. So when you want to write a gRPC service, the first thing that you have to do is to actually define the methods in your service. And as part of that, you also need to define the request and response types of your messages. And the way that you do that is by writing a proto file. And then you run that proto file through the proto compiler, and that generates code for the client and the server side. And you can control the language that this code is generated in. And once this generated code is available, you link your client and server application with this generated code, and your client and server applications will use these generated code classes, and the protocol buffer library takes care of serializing them on the wire. Cool. So one of the major advantages of gRPC is that it supports a bunch of languages. So if you're new to gRPC and you want to continue using your own language that you're comfortable with, there's a good chance that gRPC is supported in that language. And gRPC also runs everywhere. Browser, mobile, desktop, embedded, Linux, Windows, Mac, you name it. And recently we've started officially supporting Linux on ARM processors. One of the cool things about gRPC is that it provides a ton of features, but also that all of these features are extensible. So let's take an example. So name resolution. So when your client wants to talk to a server, it's going to have to resolve the name of the server. And gRPC provides a name resolution plugin that uses DNS to resolve the names. But maybe you don't like DNS, or DNS doesn't work in your deployment, then you can write your own name resolver and plug it into gRPC and use it. Similarly, like gRPC out of the box supports gzip compression. But let's say you want to use a different compression algorithm, you can write your own and plug it into gRPC.
You want to just make sure you're sharing.
So what do I do?
You're going to your backstage. You're online.
Well, it says that he's sharing his screen, and it's just sharing a blank screen.
Oh,
Maybe stop sharing and start sharing again,
Can't do that.
and then share.
You don't need the video, you just need the share screen.
Share screen.
No, he needs to refresh it just for me because his
No, he's in. He's in. Okay.
Can you see it on him?
Yeah, he should be fine. We could go back to the slides. We go back to the slides.
very good. All right. Okay. So gRPC is actively developed on GitHub. So I push all my code to GitHub. We do all our reviews on GitHub. And we also have this concept called a gRFC. So whenever we have any major design changes, we send out a proposal and we invite comments from the community. And gRPC languages, usually we try to release every 6 weeks, but sometimes we might slip here and there, but mostly we try to stick to a consistent release cadence. So let's shift gears a little bit and look at an example. So we have a fictitious application here, which is split up into a bunch of microservices, which are written in different languages. And these microservices have to talk to each other to accomplish the job that they're set out to. And so in a gRPC deployment, what happens is that each of these tasks define the service that they expose, and they write it as a proto file. And once the proto file is compiled, it generates server and client-side code. And on the server side, your task actually provides an implementation for that service. And On the client, you get what is called a stub. So a stub contains the same methods that are there on the server, but your client application can invoke methods on the stub just like it would invoke a local method. And the gRPC framework would take care of actually converting that method call into a remote procedure call and sending it all the way to the server where it eventually gets executed. And we can also have other clients which are just simply clients. They connect to the top level service. And so let's look at some of the reasons why gRPC would be better than REST or JSON. So I've gone over performance and the support for multiple languages. So let's start with security. So gRPC has built-in security both at the connection level and at an RPC level. So you can specify what credentials to use for the whole connection. At the same time, you can also specify credentials that are applied on a per RPC level. And because gRPC uses protobufs so heavily, we have type safety also built in. So because the service contract of the server is defined using protobufs, which is a strongly typed system, your client cannot send any data that's not the same type that the server is expecting. And again, because gRPC is built on top of HTTP2, we have streaming support natively built in. So let's look at the different types of RPCs that gRPC supports. So the first one is the most simple one, a unary RPC, where the client sends to the server and the server comes back with a response. So we are all familiar with this. So the other three are the more interesting ones. These all deal with streaming. So the first one is the case of a server streaming, where the client sends a single request and the server writes multiple messages on the stream. And the client keeps reading these messages until there are no more. So one common use case for such server streaming RPC would be where the client wants to download a file from the server. So instead of the server having to just send the whole, let's say you have a really big file. So instead of sending that whole big file in a single message, it can break it up and keep streaming that file. And the next is an example of client streaming, where the client sends a bunch of messages on the stream. And eventually the server collects all of those messages and then comes back with a single response. And the last one is bidirectional streaming. So here the client has a stream and the server has a stream, and they can read and write independent of the other. So the client could have a policy where it says, I'll write one message, I'll read another, and then I'll write one. Or it can say, I'll just write whatever I have, and then I'll read. So like the client and server are free to do whatever they want in a bidirectional streaming RPC. So we have a small example here. So what I have here is a definition of a service named route guide, and it has two RPCs. So these are the two methods that the server is going to implement. So you can think of this as like a really dumbed down version of a map service. So the first RPC is a unary RPC called getFeature. So basically what this does is that the client sends a point which identifies a coordinate on the map, and the server comes back with a feature which basically describes something about that point. And the second RPC is a streaming RPC, wherein the client sends like a big rectangle, and the server comes back with all the features that it knows that lie inside that rectangle. So as we saw earlier, the first step is that you use the Proto-C compiler, or the protocol buffers compiler, and pass it this proto file that you've written. And when you do that, the compiler is going to spit out code for the client. Now, the one on the right is the server. So usually on the server side, the generated code spits out an interface which contains the methods defined on the service and the server has to implement those methods. So here we see the two functions which were defined in the service. So get feature and list features, and those are implemented by the server. So your server application will implement that. And on the client, we have the stub, which again provides those same methods. And your client application can invoke those methods just like it would invoke a local procedure. And gRPC takes care of the rest of the magic. Cool. Actually, I think I'm done. Do you guys have any questions? So gRPC, so if I understood correctly, I think the question is whether gRPC supports WebSockets. Yeah, so gRPC is built on top of HTTP2. So it's going to be better than WebSockets. Sure. No, so you don't, like, when you're using gRPC, you don't have to use anything underneath it. gRPC takes care of all the networking. So let's say that if you want to build a chat application, then you define the service that your server is going to provide. So let's say for, yeah, so you'll define a bidirectional. Multiple channels, meaning you want to support multiple clients? Yeah, yeah. So, yeah, so all that is totally up to your application's control. So basically, when you run a gRPC server, underneath it's just a HTTP2 server. So it can accept any number of connections. You can probably configure how many connections it accepts. And each client talking to your server will be one HTTP2 connection. And inside that single connection, you can actually do multiple RPCs at the same time. Does that make sense? So, so I wouldn't use the word channel here. Yeah, we can chat offline. Yeah. All right, thank you so much.
Okay, our next two speakers are virtual, so we're going to take a break for a few minutes so you guys can go get some snacks. And also, I wanted to let you know, please get a mug. They're right over there. Please take them home. I don't want to take them home. So yeah, so give us a few minutes. Our next two talks are Simeon with Chrome extensions in here, and in there is Generative Art and Design with TensorFlow by Margaret. So a couple more minutes.
Oh, I see. Okay. Let's get this. I'll just give it.
Hey, Simon, just
So this is the time.
You're good.
All right.
You guys announce this one.
you're good to go.
Doing extensions 101. Simon, can you hear us?
Simon, you're muted.
Haha, I could hear you, but you couldn't hear me. Can you hear me now? I can't hear you.
Simon, can you say?
Hello, can you hear me now? I am talking. Can you hear me?
We can.
Okay. Okay, I think we're good to go. Hi, everybody. My name is Simeon Vincent, and I am a member of the Google Chrome team focused on the Chrome extensions platform. I'm specifically a developer relations engineer. If you don't know what that means, that's fine. I don't either. So today I wanted to talk to you a bit about Chrome extensions and give a brief introduction to building Chrome extensions. For those that aren't familiar, MDN has a rather nice succinct summary of what a browser extension is. And as they say, an extension adds features and functionality to a browser. Or to put it another way, every piece of software that we develop can't be everything to everyone. That the people building it make choices about what it does and how it does it, what it feels like, the constraints, the set of features they actually want to implement, and versus what they want to say other products can provide, that kind of thing. Extensions provide a bit of an escape hatch, though. We don't just have the set of things that we do. We can also allow other people to extend and customize and do new interesting things with the software that we build by building their own pieces of software that run inside it. And that's kind of the core of what a browser extension is. They let users customize their experience to better meet their needs or to just do the things that they prefer. There are a huge number of extensions published. I believe, so Chrome doesn't have any public numbers here, but last I saw, Duo Security estimated that there are around 180,000 extensions published to the Chrome Web Store. 180,000 items published to the Chrome Web Store, and about 2/3 of those are extensions. Just a few of the extensions of kind of random sampling of items from the Chrome Web Store. Honey is an extension that automatically applies coupons while you're shopping. Text.app is an extension that allows, that basically gives you like a text editor type of experience. So kind of basic system utilities. Grammarly is a spell checker and grammar checker that works across the entire web. LastPass is a password manager to, actually help you navigate the web and make the process of logging into websites more seamless. uBlock Origin is a content blocker that can help improve the speed and performance of browsing the web. Momentum is a productivity and focus tool that lives on your new tab page and allows you to kind of inspires you to focus on the things that you think are the most important. TamperMonkey is a power user tool that lets you run snippets of JavaScript on web pages and customize not only your kind of browsing experience, but the pages that you run on a day-to-day basis. And React DevTools, which I imagine some of you use, is an extension that helps you debug and understand how your React app is actually working in the browser. There are, as I mentioned, there are a ton of different extensions out there, and the things I talked about are just on the Chrome Web Store, but every major browser has their own store or kind of surface where you can get extensions. Chrome has the Chrome Web Store, Safari has the App Store. Safari's model is a little interesting. They distribute extensions as applications. Firefox has AMO, or addons.mozilla.org, and Edge has the Edge add-on store. Each of these has a whole host of different experiences for those specific browsers. And Chrome Web Store is kind of special because it powers not just Chrome, but Chromium-based browsers. So it's kind of the store for browsing experiences built on top of Chrome, or on the Chromium code base. Now, at this point, I think you have a rough idea of what an extension is and how you might use it, or why you might use it. But let's talk about how to actually build one. The core technology behind browser extensions are things that you're probably already used to working with: HTML, CSS, JavaScript, etc. So and if you've ever opened a web page on saved to your computer locally, like a .html file, and open that in a tab, you've done like 80% of what extensions do. Like, extensions, when you install them, are essentially just files on your hard drive. All of these files are just stored together into a local folder and loaded and given some access to some special APIs. When you publish an item to, say, the Chrome Web Store, you essentially upload a zip of that directory, all those local assets, and then hand them to the store and say, all right, make this available to people. And that's basically it. The primary entry point for a Chrome extension is manifest.json. So this is one of the files in that folder, and it's a JSON file that specifies things like the extension's name, what version is currently being loaded, what set of permissions that it wants to, that the user has to approve in order to use the extension. Other stuff like a permissions page or the scripts that will be injected into a website. All of that stuff is typically defined in the manifest file. So let's take a quick look at a basic example. Here we have the most naive possible minimum functional manifest. This is the content that would actually be loaded in the web browser. And when you load that, it doesn't actually do much. But this is technically a functional extension. So let's take a look at how to actually get an extension running. You open up Chrome, and you can visit the three-dot menu in the top right corner. Go to whatever that tiny text is that I can't read, and select the extensions menu. And there you'll get to Chrome extensions, Chrome://extensions, the extensions management page in Chrome. From there, in order to actually load an extension for development purposes, you'll enable development mode using that toggle in the top right. And then when it's enabled, you'll see a couple new options, including this load unpacked extension button. When you do that, it'll open a file selector, and you can navigate to the directory that contains your extension. And here you can see that we have a grayed out manifest.json file, so our minimum viable extension. And when you load that, it will up here, and that's it. Now we can see the name of the extension that we've loaded. You can see that it has an extension ID, and that's pretty much it at this point. The thing is, since all we did is give it a name and a version number and specify the manifest version field, there isn't a whole lot that it can do. But one quick thing I want to call out is that reload button. As you develop your extension, you're going to be hitting that a lot in order to actually get your updated code running in the browser. So it doesn't do anything right now, but let's fix that. Let's make it do something. Let's make it actually work. So now we'll start to get into actual code. If I can remember what we were doing here. Oh, right. So for the purpose of this, I first want to show you kind of a simple extension that I've used to prepare this talk. As you can see, I have a lot of screenshots, so I wanted to have consistent sizes on my screenshots. And in order to do that, I built a simple extension that will let me resize my browser to a specific set of dimensions. So to start off, we're just going to resize the browser a little bit. As you can see, now we have a smaller window. This is the experience that we're going to implement, by the way. So we're going to go to the extension menu, which is that little puzzle piece in the toolbar. You can see that there's currently a single extension. We're going to go ahead and click that guy. And then we'll have a little pop-up here that allows us to specify a height and width in integer values. And then you click the resize it button, and boom, boom, it gets resized to our desired dimensions. Now let's talk about how to actually make that happen. Here we have our manifest.json file. As I mentioned, we only have a name, a version, and a manifest version. We don't need to dwell too much on any of these, but the one important thing I want to call out is we're currently going through a transition process between manifest v2 and manifest v3, and this is like the most concrete way that that manifests. Sorry. So the first thing that we're going to do in order to make this extension do something is we're going to declare that it has an action. An action is just that thing that appears in the toolbar in Chrome. And we're going to set the default URL for that to popup.html. Ooh, that's the new interesting bit. Next, let's look at the contents of that HTML file. As I mentioned, this is all just standard web tech. So first up, we're going to declare a source file of a page.js. That way we can actually do something with this HTML. And then we're just going to have a simple UI. Very basic, doesn't do anything fancy. We just need to accept inputs and then do something with them on submission. Here we have popup.js, the actual heart of this particularly simple extension. We have an event listener, so when the form is submit, we will prevent default. I'm just in the habit of doing that, I guess. And we're going to instantiate a form data. Then on the form data event, we're going to actually fetch those values and manipulate them in order to expose them to, in order to actually do something with Chrome's APIs. The height and width here are being dynamically fetched from the form, and the only like particularly special extension logic we have here is that we're setting the window dimensions. We're using the update method to specify the height and width for the current window ID. Oh, I guess we skipped over it, but there's also here at the top of this, let win equals await window get current. So that's the other, I guess, special bit is that we're actually getting the currently focused window that the user is interacting with. That's all of our pop-up script. So now let's talk about some background stuff. Oh, right. So all of those together, that makes the experience that we just saw, where you're able to click the extension icon, get a little window that will resize it, and then when you click resize it, that performs the resizing operation. So that's just one way that we can implement this. Another is that we can actually do some stuff, some work in the background without the user having to directly interact. So let's take a look at that kind of an alternative implementation of the thing that we just did. But this time, we're going to be using a background script instead of a pop-up. So in this case, we have the action because we're still going to be using that clicking event to do something. But in this case, we're going to declare our background script in manifest v3. That's a service worker. So we're going to have our service worker listen for events and then react to them. So as I said, we continue to have the action and then we declare the service worker. Now in the background, instead of dynamically fetching values, we are going to have a static height and width that we're going to set. In this case, the default values before were the 600 and 900 that we have here. But since we're going to be doing this in the background, we don't want to actually have a pop-up. We just know that we want to set everything to the right size and height and width. We're going to statically declare those. Then we have the .action.onClicked call. So when the user clicks the action in the toolbar, we're going to react by first awaiting the result of getCurrentWindow, because we want to modify a specific window. And then we're going to perform the update with our static height and width. That's pretty much it for that. That altogether does the same thing that our pop-up version did, except without the ability to dynamically size it. And you can also see by extension that if this operation is being performed in the background, we can extend it and do things like, I don't know, on a timer, do this kind of update, or potentially have some other signal that we interpret to mean, hey, the user wants to resize the current window, maybe say performing a keyboard shortcut or something. Another core concept in extensions are content scripts. And while the demo that I was showing before doesn't actually flex this idea, there's kind of no need for it. It is something really important to kind of just getting your feet wet with extension development. So let's take a look at a terrible extension that is not important at all, but functionally shows you some basic ideas. So here again, we have our super simple manifest.json. Doesn't do anything, except this time we're going to have it declare a single content script in the manifest. And then I just happen to be working on a demo at this time, .proto sw fetch demo.glitch. That site is just something to experiment with service worker lifetimes. And in this case, we're also going to be having a JS file, content.js, that gets injected onto that site automatically every time the user visits. So to do that, we have to declare some script. As I said, this is a terrible demo. All it does is alert. Normally, when you visit that site, you would see something like this. But because we have a content script declared, and Chrome will automatically inject and execute that script at the start of the page load, if we have the extension loaded, you would instead see this, where, like, as you can tell, the font isn't loaded, that like the HTML parsing is in the process. But because the script is injected automatically early enough in the page's loading process, all of that gets interrupted, and because of the blocking nature of alert calls, none of that renders. So this is exactly what you would see if you loaded that very bad extension. Now, we've barely scratched the surface on extension development. There's a ton of other stuff that we could get into. We could talk about like isolated worlds, like how content scripts are loaded, the multi-context nature of extensions, that you're passing messages between multiple pieces running in different areas, different parts of the browser, passing messages between those areas, the event-based nature of service worker style background contexts, how to request permissions and what kind of permission prompts users see, user experience practices, etc. There's so much to cover in extensions, but in terms of getting your feet wet, none of that really matters. All that matters is this is like an HTML, JS, CSS stuff that's being loaded in your web browser. And it's actually super easy to get started. I'm hoping that some of you may be seeing the potential to experiment with and really customize your experiences on the web. One of my favorite ones that I personally use all the time is I spend too much time on Twitter, like I imagine some of you do. It just hides the trending stuff. Like I have a CSS selector that just makes that disappear because it improves my day-to-day life more than I could say. I highly encourage you all to experiment with and try out extensions. I think they're super cool, and I hope you will as well. And that is it. Thank you very much.
Let's just do. I'm gonna need to figure out exactly what so hang on. Right, so we're here to talk a bit about standalone components, which is something that Mark mentioned earlier today in his talk. But before we do that, we have to go back. Is it not? 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 We have to go back. Modules to Angular, they're essentially a way of allowing you to group functions of code all up into one little a module, something you might reuse. And they are something that you use to handle declaring dependencies. So like components, directives, and pipes that you're going to use in your application. Dependency management overall. So your modules are a way of dealing with declaring really any dependency you're going to use within your application. Is it not sharing? All right, hang on. Not sharing again. All right, this one is the one we want. And there we go. Can you see it now?
Yes.
Okay. About that. So yes, modules are dependency management, and they declare a functional unit of code. What's interesting, probably to a lot of people who've used Angular before, is that modules actually weren't part of the original design for Angular. They actually came about as a need to solve the issues of fine-grained dependencies. And we struggled with the idea of how we were going to do that, and we kind of settled on this idea of modules, but we've actually never really been happy with this at all. Igor Minar, former member of the Angular team, helped build Angular initially, has said a lot about this in the past. We've just never been a fan of it, and we've never really had a good solution for solving this problem. The problem here is that modules often create confusion, and this has a lot to do with the fact that modules are a form of indirect dependency management. So you have your component and you have your module. You have to declare all of your dependencies in a separate file rather than the component that you're using it. And this leads to a bunch of confusion. So there's a bunch of additional steps in direction that comes from this. It's a lot of additional boilerplate that you have to deal with. There's more difficult debugging and troubleshooting due to the fact that maybe you've written your component and you've got your module and you're like, why am I getting this error in my component when I'm trying to run my app? It's saying that such and such thing is missing, but the thing I'm looking at, I don't see where this is coming from. It's because it's in an indirect dependency management. It's something to do with the module, not the component. So that's very confusing. And this also adds a lot of complexity. So there's some trade-offs that come with it. You get this nice modularity, but you also have a bunch of complexity that comes along with that. The learning journey is confusing for new engineers that are learning Angular because of this as well. So if they've used a different framework, they come to Angular and they're often like, what are these module things? I've never had to deal with this anywhere else. Why do I have to deal with this here? It can be very confusing and almost as difficult as learning or knowing when a bolt of lightning may strike. It's a little challenging in that regard. So some workarounds have come around to solve this problem, and the SCAM pattern is one of those. That's, as you can see, stands for single component and module. And essentially when people use this pattern, they are creating their components and immediately creating an associated module that lives right next to it. And it essentially, they live together in one unit, and there's just a bunch of modules proliferating throughout your app to make these components a single unit that you don't have to think about beyond the module. So you don't have to deal with as much of the indirect dependency management, even though there is still that separate file. It's just a bunch of extra boilerplate code. There are people out there who really do like modules. They think that they make a lot of sense, but a opinion here is like, who needs these things? I don't want to have to deal with them. And this here is an example of what you might see in a module. And please see of this module, I didn't have time to build it to scale or to test it. Additionally, you'd have to create all these additional files being imported here as separate files. So, you know, there's a little bit of indirection there. Standalone components essentially means less of this code. So, hey, Gray's Sports Almanac module, make like a tree and shake on out of here. That's the phrase, right? It's leave, isn't it? Ah. Anyway, be careful where you trash this module too, because you never know who might find it in a trash can and then like in the future and change the future. You don't want that. So anyway, back to standalone components here in the future, or is it? It's the present, isn't it? Yeah, it's the present. Let's talk about standalone components. So what are they? They are components that stand all by themselves. They don't require a module. They manage their own dependencies, and they work all by themselves. Here's an example. You saw something similar in Mark's talk earlier today, but you'll notice this standalone true, this imports array that's directly in the component decorator here. You can also have your providers as well. And the great thing about this is this means that components are now the central concept in Angular. There's no need to go searching for which module you're going to, need to declare your dependencies in. It's just right there, right in the component. This reduces that heavy cognitive load. The mental model is overall much simpler because of all of this. So the SCAM pattern is no longer needed when you're using standalone components, and that's great. So and there's less friction. There's a simple, more simple flow when you're building your applications. And you're probably asking yourself right now, but Jessica, I already have this big application that has a bunch of modules in it. Am I going to have to now write a big migration to have to deal with all of this? And the wonderful answer here is no. The reason for that is standalone components are backwards compatible and interoperable with modules. So if you want to use standalone components and you've still got some modules lying around, you can do that, and that's just fine. So don't worry, you won't be docked if you modules. Okay, so how do standalone components actually work? That's a good question. But one of my components, all right, so now I've got to manage dealing with how I'm going to move this demo over to this other screen and do the demo. So maybe what I'll do is I'll turn around and code the screen. We'll see if that'll work. Oop. That's not what we want.
just sharing your whole screen. So.
Okay. All right. So let me. Not allowed for this. I want this to tip over here. So. Oh. Here we are. We're in VS Code. This is a new Angular app. We've got. And we'll have to open up a terminal window here. Is taking its sweet time. The demo gods are not in my favor today. Come on, VS Code. Do your thing. Oh, that's probably what it was. It was like, hey, I want to now.
That's what I saw from the computer.
Okay. Now we've actually got our we're going to start off, we're going to generate a component here, and we're going to call it time machine. And we want, so we'll make it standalone, just like that. If you haven't ever worked with Angular, we have this awesome CLI of this stuff. So nice folder that lives inside the app here. You can see the right here. So we've got our actual class, and we've got some HTML. I'm going to actually pop in and just make time content, our time style, so that I don't have to waste time typing that out. You'll notice we've got some red squigglies here. That's because, well, we've got a time machine. Time machine has to go fast, right? Miles per hour, but we're going to start with it. And now we should be all good. So we've got our first standalone component here. We actually need to convert our app to Bootstrap with Standalone. So the first thing we're going to need to do is come to our main app component here and just simply add Standalone true. Now that's done. We have this module file, and you can see there's maybe a dependency in here, the router module. We'll come back to that in a second. We've got our main TS file. This is the file that actually bootstraps your application. And we need to quick change this. Now, what I'm doing here will eventually be in the CLI directly. It is not yet. So we want bootstrap application rather than module bootstrapper. So we can get rid of that, and we can pop this out. We can say bootstrap application. And you'll notice we're still using a module here. We actually don't want to do that. We want to import that app component. So there's our app component, and instead we want this to be app component. So that switches our Bootstrap over to using a standalone component. That's pretty much that simple. We're going to need routes. So we'll be doing that next, but now we actually don't need this module file anymore, so we can just delete it. Okay, so we're gonna need some routes. And in order to do that, before we imported a whole router module that we had to use, and now we just do a couple of things here. We need to import routes and provide router. from Angular router.
Our bootstrap.
We need to provide them to our application. So provide and provide router. This is a function and it's going to take some routes. So we need to define those. And since we're building a time machine, our time machine needs to be able to go like the past, the present, the future. So we'll go with some routes like that, right? There's our three routes. So we'll just reference these in provide router. And that's all good, but we're missing these three components, right? They're not imported here, so we need to do that too. So import past component, we need import present, and we need to import future. Awesome. And that's all it takes. So a lot of applications will declare these routes in a separate file and then import them here. I'm just doing it here in the file for the purposes of the demo because it makes it a little bit easier.
Jessica, can you share your screen one more time with the online?
I've seen it.
Isn't it? Okay, Maria, okay, good. If it's working, then never mind.
Great.
Sorry.
Okay, so there's one last thing we'll need to do with our app component. Our main app is actually using this router outlet, which is something that we need for routing purposes. So let's actually import that here as well. So our imports will need router outlet, just like that. And I think we should be actually able to run this app now. It's not a very big app, so it shouldn't take very long. Yeah, there it goes. So if I click, we've got a time machine.
Let's go.
So we're going to do a couple more things since, you know, you need something to power your time travel, right? That's a flux capacitor, right? We need a flux capacitor. So let's quick do that here in our. So we'll go ng generate component. Yeah, I know. I could just do ngg, but I'm not. Great. So now we've got a flux capacitor here. Let's
Content. So
flux content. Oh, you can see we're going to have some gigawatts. There we go. Yeah, so a flux capacitor provides power and it provides a lot of gigawatts. So we're going to need some gigawatts. All right, is our component happy now? Yes, it is. And it's probably a good idea for us to reference in our template for the time machine, our flux capacitors. So let's do that. Great, now you'll see the red squigglies, and that's because in our component, we haven't actually imported it. So let's do that. And we should be happy now. Look at that, there we go. So we serve this again. Building, there we are. And we can refresh this page. And let me guess. There it is. See, we got our flux capacitor right there. It's a nice little window right into the back of the car where you can see it. Okay, so the last thing we're going to need to travel through time is the actual bolt of lightning, right? So we don't really have to worry about the whole clock tower thing. So we'll just create a service. Sounds good, right? Except for I spelt it wrong, right? That's great. There we go. Okay, so now we got a Lightning service. And in our Lightning service, let's just do a quick, wrong arrow. Great. Never mind the spacing for the purposes of this demo, but you can see here we've got a striking, we've got some power, and it's just a simple number. So let's make sure that our two components actually have a reference to this. So our flux capacitor will need to DI our Lightning service. And we're going to need to make sure our gigawatts are updated whenever that power changes. And here we've got the same thing we got to do here in the time machine. So private. And in this case, if .lightning.is striking, this .speed 88. Great. All right. So let's serve this up. Okay. So our app is still working, but you'll notice it's not actually traveling in time yet. So let's head over to our Lightning and we'll make sure our Lightning is striking. There it is. Okay. So now you know how to use standalone components.
Let's go.
Awkward turning around again. And I'll have to figure out how to get back to my slides.
Awesome.
There we go. Okay. All right. So now we've taken a look at this and you've learned that you don't need money and you don't need fame and you don't need no ng module to ride this train. Thank you, Huey Lewis. As Mark mentioned, these APIs are currently in developer preview, which means they're kind of in flux. It's really just for the purposes of using this joke. They're not really in flux anymore at this point because they are going to be stable in V15 in a couple of weeks. But even with that, we would still appreciate it if you go and play with them. And we appreciate the feedback. The future of Angular depends on your All right, I'm out of time. But before I go, I just want to say a couple of things. I know that like the past several years have been kind of challenging and we all go through very difficult times. Sometimes times get really tough. I just want to remind you all that, hey, you are capable, you are valid, you are loved. Please take care of yourself. If you're struggling, know that these are all available to you. Go and crush your goals. You wonderful people. It is your density. I mean destiny. It's your destiny. You're all amazing people. You really do truly deserve the best. My name is Jessica Janik. I'm a senior software engineer on the Angular Framework team. I'm also known as Darth Vader from the planet Vulcan. Live long and prosper, everyone. I'll leave you with this.
Thank you so much. That was awesome. The only announcement right now. Okay. We're gonna wait for the other room to be done and come out, and then we'll have our last closing announcement. So please stick around. We do have a couple prizes. Also, please take a mug if you haven't already. Couple minutes. Thanks.
Sorry for making your job.
The striking right is not sending the screen. That thing is big old. The next time with the demo.
How do I announce on this track that we're done with the broadcast for this track? The rest of the other ones. Oh. Okay. Okay. Thanks everybody for joining online. This is the end of the broadcast for the main track. The cloud track is finishing up right now. Thanks for joining. See you all soon.